Welcome to Study Time with Kat. I am Kat, and this is Study Time. I'm trying to get my statistics homework done. Currently working on the t-test for 2 related samples. And I just need to talk to someone, and it felt weird to talk to myself, but less weird to talk to a camera. So that's why you're here. We're going to be listening to Vivaldi, the Seasons, and then there's also like Allegro molto, Allegro non molto. There's like a whole bunch of things. Also, we're gonna go for it. So let's just, I don't know if you can hear it, but I can hear it, and that's all that matters. I like studying to classical music because if there's words, then I sing and I don't pay attention to what the words are saying. Okay. Repeated measures experiments measure the same set of research participants 2 or more times while matched subjects experiments study participants who are matched on 1 or more characteristics. Okay, so repeated measures, same people, twice or more, matched subjects once, but they're paired together. Great. Matched or matched. Makes sense. Which of the following are true for both related measure or repeated measures experiments and matched subjects experiments? When used to compare 2 treatment conditions, check all that apply. They both use the same T statistic. I mean, they use the same chart. They use the statistic to see whether or not they're together, right? Yeah, because it's the mean differences. So they both use the same T statistic. Research has an n number of participants to use in the experiment, then the degrees of freedom will be the same in a repeated... Degrees of freedom is always n-1. So yes, that's true. The research must compute an estimated standard error for the mean difference score to compute T statistic. An estimated standard error of the mean difference to compute. Yeah, to get to this T statistic, you need the variance. And the standard error is the variance unsquared. Square rooted. Pooled variance. Do I need a pooled variance? No, pooled variance is the SP squared, right? That's an SD squared, which means it's the difference, right? Right? I literally just worked on the two-tailed... Yeah, the pooled variance is... Okay, we don't need the pooled variance. We don't need the pooled variance. But I think we need the standard error of the mean. Okay. For repeated measures experiment comparing the 2 treatment conditions, the T statistic has a degree of freedom of 31. How many subjects participate in this study? 32, because degrees of freedom is n-1, so n plus 2. I mean, n plus 1. I mean, degrees of freedom plus 1 equals n. Wow. Okay, it's 32, because 31 plus 1 is 32. I can do that math. The matched subjects experiment produced a T statistic. Degrees of freedom of 9. How many subjects participated in this study? Oh shit. Number of pairs of scores is the degree of freedom for a matched. Oh, so up here, that one isn't right. If a researcher has n number of participants, then the degrees of freedom will be the same. No, because it's the number of matched and not the number, not n. Matched subject. So there's pairs. So number of pairs, there's going to be 10 pairs. So there's going to be 20 people graded. Got all of them right. Excellent. I don't know if I can, this is copyrighted. We're not going to show you. We're just going to talk. Okay, continue. Question number 4. How many questions are there? 11 questions. Oh god, this is going to be long. Okay, question number 4. Calculating the standard deviation and the estimated standard error for the sample mean difference. Researcher is interested in hamster wheel running activity during the summer versus during the winter. Why? She suspects that either the hamsters will run less during the winter to conserve energy, or they will run more to keep warm. You can't see my eyebrow, but I was like, that's weird. This guy's really into hamsters. She records the activity of n=16 hamsters during June, July, and August and compares their wheel running revolutions per hour to the activity of the same hamsters during December, January, and February. Okay, so we have for summer n=16 and winter n=16. I feel like I might need to write that down. What is this girl doing? Ugh, being birthed. Okay. The data are collected and the results show an average difference score of mean difference equals 3.8. The sum of squares is 522.15. What is the value of the degrees of freedom for this repeated measures test? It will be 15. My email just popped up. I don't want that. Go away. That is the sample standard deviation S for the difference of scores. Okay, so we want SD. We do not want, we want SD. We want the standard deviation for the difference of scores. So standard deviation is equal to the square root of the sum of squares difference over the degrees of freedom. So our degrees of freedom are 15. So let's put that in there, 15. Our sum of squares difference is 522, 15. 500 with my calculator. I'm not going to do that by hand. Okay. 522, 15 divided by 15 equals 3481. So 3481, and then you have to square root that, which is 5.9. So 5.9, which is an answer. That's the sign that you're doing something right. If the answer that you get is an answer that's given in the multiple choice. Okay, what is the estimated standard error of the mean difference for this study? So SMD, how do I get, okay, there it is. Okay. So to get SMD, I need to take the number that we just got, this standard deviation of the difference of scores, and then divide it by the square root of n, not degrees of freedom, the number of people in the experiment, or in this case hamsters. Anyway, okay, so we just got 5.9, and then divided by the square root of 16, which is 4. 5.9 divided by 4, gonna be at least 1. Okay, 1.475, which is not an answer, but 1.48 is, which is 1.475 rounded up. So we're just gonna call that good, grade it now. We are correct. Booyah. Can I take a picture of this? Okay, Megan texted me. I love her very much. Okay. Heart. Whenever I love her very much, but I've already said I loved you like 4 times in a day, I just send her hearts. She seems to be okay with it. I don't know if she'd tell me if she wasn't. Okay. Number 5. Okay, number 5. Let's draw a line underneath that work so we don't get it confused. I need a ruler for that because my homework needs to be pretty. Otherwise, what's the fucking point? Okay, number 5. A step-by-step hypothesis test for repeated measures design. Consider the following data from a repeated measures design. You want to use a repeated measures t-test to test the null hypothesis. The mean equals 0. The null hypothesis states that the mean difference for the general population is 0. This data consists of 5 observations, each with 2 measurements A and B taken before and after a treatment. Assume the population of the differences in these measurements are normally distributed. Okay, complete the following table by calculating the differences and the squared differences. Okay, observation 1. A is 1, B is 3. The difference of the scores is B minus A, so 3 minus 1 is 2. God, this would be very embarrassing if I got that wrong. 2 squared is 4. Pretty sure. Okay, observation 2. A is 3, B is 4, B minus A, 4 minus 3 is 1. 1 squared is 1. Okay, observation 3. A is 5, B is 7. 7 minus 5 is 2. 2 squared is 4. Please tell me I'm getting these right. Observation number 4. A is 4, B is 4. 4 minus 4 is 0. 0 squared is 0. I know I got that one right. Okay, observation number 5. A is 8, B is 9. 9 minus 8 is 1. 1 squared is 1. Let me just double check that. Yep, 1 squared is 1. The mean difference of the scores. Oh, god damn it. How do I get mean difference of the score? I feel like I just did the work. Mean difference of the score. That'd be all of those added up and divided by 5. Let's try that. It's going to be one of these. 1, 2 plus 1 plus 2 plus 0 plus 1. I'm not doing that. That's what, yep, we have enough. Is 6 divided by 5 is, no, there we go. 6 divided by 5, 1.2. Okay, so it could be 1.2, or it could be 4 plus 1 plus 4 plus 0 plus 1. How do I set that? That's what, yep, okay, we have 5 equals 10 divided by 5. So it's either 1.2 or it's 2. 1.2 is our only option. So it's the difference of the scores, the mean of the difference of the scores, which, saying that out loud, it seems obvious. But it's not the mean of the squared differences of the squared. I don't know what that is or if that's even... Oh, that's the sum of squares difference. Excellent. Okay, well anyway, the answer is 1.2. For repeated measures t-test, you need to calculate the t-statistic, which requires you to calculate S, and the SMD, which is actually, like, it has a name. Standard deviation of the mean of the differences of scores, but SMD is less words. Okay, what is the estimated standard deviation of the difference of scores? There it is. SMD equals SD. Holy shit. Okay. That's gonna be, oh god damn it, no, that's N. That's N. So, the sum of the differences squared minus the sum of the differences squared. What? Sum of the differences is gonna, I think it's gonna be this one. I can't see what I'm talking about. Let me take a picture. I could be very wrong. N equals 5. 2.8 divided by 5 equals 50.56. We're gonna go with that. Okay. What is the estimated standard error of mean difference scores? Note for best results, retain at least 6 decimal places from your calculation of S. I only have 4. 2.8 divided by 5, it gives me 2 decimal points. Okay, SMD equals S divided by square root of N, right? Which equals, so 5.5601 divided by the square root of 5, so 5, oh, that's a decimal, 5601 divided by the square root of 5. The calculator says that is 0.250. How many? 6? Is there some multiple? Okay, 2.5. Oh no. Nope, my answer is not here. Okay, that's when you know you fucked up. Okay. This is degrees of freedom, so this is n minus 1, which means this is 4. 2.8 divided by 4 is going to be an even nicer number than what we had, is 0.7, which is not an answer. Okay, so we were closer with the first one. Okay. I don't know what I'm doing. We're just going to randomly choose one. Okay, we've chosen that one. Okay, what is the t-statistic? Oh my god. What is the t-statistic? What is the t-statistic for the repeated measures t-test to test the null hypothesis? Mean differences. Oh my god. Okay, what is that? We have to find that. It's not given. Oh, okay. Nope, I have to do it. Degrees of freedom is 4. 1, 2, 3, 4. Nope, that's not what I was doing. Oh, it's 0. The mean difference is gonna be, yeah, the mean difference of the population if the null hypothesis is true is 0. Wow, I overthought that one a lot. Okay, you conduct a two-tailed test at alpha equals 0.05. My feet are cold. My heater's on now. There's gonna be extra noise. Okay, the degrees of freedom are n minus 1 equals 4. The critical value is the value for the t-score that separates the tails from the main body of the distribution of the critical region are plus or minus 2.776. Finally, since the t-statistic is in the critical region, you reject the null hypothesis. I think I got the math wrong, but I think I got the rest of it right. Yeah, I got all the math wrong. Okay, that's fine. Now I know what is wrong, which is that. And let's see what is right. Okay. Let's try that again. Try another version. Okay. Considering the following data. Okay. Observation 1 is 1, B is 2, 2 minus 1 is 1, squared is 1, 3 minus 3 is 0, squared is 0, 6 minus 4 is 2, squared is 4, 5 minus 6 is negative 1, squared is 1, 8 minus 6 is 2, squared is 4. That is a 3 cat. 4. Okay, the mean difference of the score is MD, mean difference 1 plus 0 plus 2 plus negative 1 plus 2 is 4, divided by 5 is 0.8. Is that one of my options? Yes, it is. Okay. Oh, okay. We had this, and I took a picture of it because that's how I do my homework. Okay, so it's the sum of the differences squared minus the sum of the differences squared divided by n over n minus 1. So the degrees of freedom are 6.8 over 4, or whatever the degrees of freedom are. 4 is 4. 6.8. Oh, what I did wrong. I didn't square root it last time. Ah, god damn it. 6.8 divided by 4, and then square root the whole thing equals square root of 1.7. It's so frustrating when you figure out what you did wrong after you've already done it. 1.3038. That went far enough out. Okay, 1.3038. There it is. Okay, what is the estimated standard error of the mean of the difference of scores? Okay, SM is S over the square root of n, which equals, here we go, let's put it in. We found s to be that, so s over the square root of n equals 1.3038 over the square root of 5, because n is 5, which equals, that's an 8 cat. Okay, 1.3038 divided by the square root of 5 is 0.58308. It's 307708858, but we're just cutting it short. Okay, 5831. That works. Okay. We already did this. If the null hypothesis is true, the mean difference of the population, the difference of the mean of the population would be 0. And then that is over SMD. Our degrees of freedom are 4. Our alpha level is 0.05, which makes our degrees of freedom are n minus 1 equals 4. The t-scores that separate the tail from the main body, forming the critical region, are plus or minus 2.776. Finally, the t-statistic is 1.37, is not in the critical region, so therefore you do not reject the null hypothesis. Rate it now. Fuck yeah! Kind of cheated. It's fine. I did it. Okay. I have to get this done in an hour and 45 minutes. We got this. We're already on question 6. I was about to be like, it better be question 6 if I forgot. And it wasn't all of a sudden 6. Okay, so this was 5. Make my line so I don't cross-contaminate. Sometimes I feel bad for wasting paper. And other times I realize that this notebook was already made and I need to write things down. If I had like a tablet, I feel like maybe I could do that, but I don't have the money for that. Okay, regardless. We're on 6 of what was it, 11? Of 11. We're like halfway there. Almost. Number 6. A two-tailed hypothesis test for a repeated measures research design. Previous studies have shown that playing video games can increase visual perception abilities on tasks presented in the gaming zone of the screen, within 5 degrees of the center. Do I need to know that number? Probably not. A graduate student is interested in whether playing video games increases peripheral visual perception abilities or decreases attention to the peripheral regions because of the focus on the gaming zone. Okay, so there's like a box of your screen and then the zone is like here, and whether or not you can focus on the outsides of the box is what we're focusing on. Okay, I don't know if that was important. For her study, she selects a random sample of 64 adults, n equals 64. The subjects complete a difficult spatial perception test to determine the baseline of their abilities after playing an action video game, a first-person combat simulation. For 1 hour a day over 10 days, they complete the difficult perception task for a second time. Before playing the action video game, the mean score, before video game, BV. The mean score was negative 0.08. The mean of the differences between each person's pre and post. Oh, never mind. I got that wrong. Cross that out. Okay. Before and after, the mean was, before playing the video game, the mean of the score in their accuracy on the spatial task was 0.42. After playing the video game, it was negative 0.08. It definitely dropped. It's just determining whether or not it was statistically significant. The mean of the differences between the person's pre and post scores was 0.5. So mean differences equals 0.5 with the standard deviation of the differences, where standard deviation of just SD is 2.4. Okay, the graduate student has no presupposed assumptions, which means it's going to be two-tailed, but we already knew that from the title of the question. Thank goodness for those titles. Graduate student has no presupposed assumptions about whether playing video games increases peripheral visual perception abilities or decreases attention to peripheral regions because of focus in the gaming zone. Wow. So she formulates, I love how most of them are she's. I feel real great about that. So she formulates the null and alternative hypothesis as the null. The mean difference is 0. Alternative, the mean difference is not 0. She uses a repeated blah blah blah. She uses a repeated measures t-test because the sample size is large. If the null hypothesis has true equality, the test statistic follows the t-distribution. N minus 1 equals 64, minus 1 equals 63 degrees of freedom. Oh, it's just saying that the degrees of freedom is 63. Got it. Degrees of freedom is 63. This is a two-tailed test because we have no presupposed assumptions as to where it's going to go. Use the significance alpha level 0.01. Ooh, she's small. Okay. The critical scores are plus or minus 2.656. To calculate the test statistic, you first need to calculate the estimated standard error under the assumption that the null hypothesis is true. The estimated standard error is... oh, God. What are my options? Okay, well, there's definitely math. Let's look at my paper. Okay, the estimated standard error... okay, it's the SMD. Estimated standard error, SMD. Got it. Okay, to get SMD equals, I don't have sum of squares. Oh no, I already have the SD. Okay, that's 2.4 over, so SMD is SD over the square root of n. So 2.4 over the square root of 64. So that is 2.4 over the square root of 64. That is 3/10 or 0.3. Is that one of my options? Yes, it is. The test t statistic is, okay, so that's t equals md minus mu d over smd, which is 0.5 minus 0 over 0.3, which is 0.5 over 0.3. In actuality, okay, 0.5 over 0.3 is 5 over 3, which is 1.6666666666666. It's probably going to be 1.667. Why is it a negative? That's my only option, so it's 1.67 and it's negative, but I don't know where it got negative because 0.5 minus 0 is a positive number. Unless, what's our point? Nope, it's 0.5. Oh, but we could have, it's, okay, never mind. I think I got where that comes from. Anyway, use the tool to evaluate the null hypothesis. Note, you can place the purple line. Okay, so I have to put the purple line. This is just so that I get extra points. Okay, negative 1.67. I can already see that it's within the critical region. I mean, it won't let me move any further than that, so we're going to call it good. The t-statistic does not lie within the critical region for a two-tailed hypothesis test. Therefore, the null hypothesis is not rejected. The graduated student cannot conclude that playing video games alters peripheral visual perception. There it is. Clearly had some effect, but was it statistically significant? No, it could have been due to chance. The graduate student repeats her study with another random sample of the same size. This time, instead of the treatment being playing the combat simulation game, the treatment is playing a soccer video game. Go FIFA. Suppose the results are very similar. After playing a soccer video game, the mean score was still 0.5 lower, but this time the standard deviation difference of the mean was 0.18. This means that playing the soccer video game has the more consistent treatment effect because the standard deviation is smaller. That means the variability is smaller. That means all of the scores were closer together. The difference of the standard deviation also means that 95% confidence interval of the mean difference would be, okay, would be wider for the original study because the standard deviation was larger. The treatment was playing the combat simulation game than the 95 confidence level. Right, because there's a larger variance, which means that your confidence level has to be wider to cover that extra variance. Finally, this difference in the standard deviation means that when the graduate student conducts a hypothesis test testing whether the mean difference is 0 for the second study, she will be more likely to reject the null hypothesis than she was for the hypothesis test you completed in the original study. Right, because there's going to be less chance, and if it was already such a small chance that she would get that, then okay, grade it now. More likely. Are we grading it? Please grade it. Here we go. Yes. Yes. We got it all. Continue. Number 7, measures of an effect size for the repeated measures T. Graduate student is interested in whether journaling can affect grief and healing. I believe it does. I think it's a personal opinion though. For her study, she selects a random sample of 64 adults, n equals 64, who have been widowed within the past 10 to 14 months. The subject complete a battery of psychological questionnaires before and after spending 2 months journaling about their emotions. Before the 2 months journaling, the mean score of the impact of event scale avoidance subscale, which measures, okay, we're going to ignore that, was 15.4. So the mean, first one is 15.4. And then after months of journaling, the mean score was 0.8 lower, which means I have to do math. 15.4 minus 0.8. Ooh, that is 14.6. I don't want to do that in my head because if I fuck that up, I'm fucking up the rest of it, and we don't need that. Okay, the graduate student. So the mean difference is 8. Assume that the data satisfies all the required assumptions for a repeated measures T test. So our mean is -0.8, our standard deviation of the differences is 1.9, our standard error of the mean of differences, the SMD, is 2.375, that's 0.2375. Our degrees of freedom is n-1, which is 63. The T statistic is -3.37. The critical value when alpha was 0.05 is plus or minus 1.998. Notice that the T statistic is in the critical region, making the hypothesis test significant when the alpha level is 0.05, the 95% confidence interval from the mean. Okay. Confidence intervals are difficult for me, and I don't know why. So we have the mean. Okay, the mean of the differences. M1 minus M2, -0.8, plus or minus S, which is 1.9, times the T value, which is 1.998. Okay, 0.8 plus, actually, let's just 1.9 times 1.998 is at 7 instead of 1. Okay, so that's going to be -0.8 plus or minus 3.7962. -0.8 plus answer equals 2.9962. And then minus answer is -3.7962. Oh, I did that wrong. I'm guessing. Okay, use Cohen's d to calculate the effect size. The absolute value of the estimated d is md divided by, md is -0.8 divided by st, which is 1.9, which equals 0.42105. Okay, this is a small to medium effect size. Use r squared to calculate the effect size. R squared is t squared, so 3.37 squared over 3.37 squared plus the degrees of freedom, which is 63. That makes it 3.37 squared over 3.37 squared. Ooh. Plus 63, that is 1527, which means on average, what? Oh, 15. 15%. Read it now. Got it all right. Okay, my battery's dying and I can't be bothered to plug it in because I actually do need to get this homework done. But thanks for joining us. And I will see you maybe next time, maybe. I don't know if anyone wants to see this. Okay, bye.